Okay, hey guys. So welcome back to our second attack detection fundamentals workshop. Today we're going to be covering code execution and persistence. So I'm just here to give a brief introduction to the series and to this workshop in particular, and then I'm going to hand over to Anartz, who's going to be covering everything from there. So just a quick introduction for Anartz. So he's one of our threat hunters at Countercept. So he's got a really interesting real-world example that he's actually been studying of the Astaroth malware. So my hope is that you're going to find this lab really interesting, and it's going to cover a lot of really interesting kind of attacker techniques all bundled into a couple of labs. So it should be really cool. In terms of the goals of the series, so you should be familiar with this if you've seen the first of these, but essentially, as I said before, classic offensive informs defense. We're going to look at all of the techniques that are kind of at play within this kind of malware, and understand how we can detect those things, and ultimately how we as a whole can prevent those things. As I said before, again, this isn't supposed to be like an exhaustive look at every permutation of detection. As I've kind of referenced before, Jared Atkinson's blogs on capability abstraction and the funnel of fidelity are two good reads if you're looking for kind of a wider understanding on building effective detection or understanding the limitations of the detection that you've built. And the other thing to add as well, of course, is that what we're talking about here, quite rightly given the name, is very much fundamentals. So we're not going to look at how we scale this up, how enterprise products kind of deliver what they deliver. This is very much kind of what we think is what it all boils down to. If you understand these concepts, the likelihood is that they're at play within your vendor products, and this is what's kind of behind the scenes. Obviously, those products are going to have additional stuff, as I mentioned before, external IOCs, or IOC feeds, data processing, analysis, all of that stuff. But we think it boils down to these fundamentals. So how we're going to do this, just as before, analyze, emulate, observe. So we're going to take the Astaroth malware and understand the various components of the techniques that are at play. We're going to look at the known TTPs. We're going to use MITRE to some degree to kind of try and categorize what they are. We've got another simple lab environment that you should be able to just work out with a couple of virtual machines. And then we're going to observe what we see from this. So what traces do we have for our detections? So how we're going to do this before we jump into the action again, as I said previously, simple lab setup. So as you can see there, we've got just a brief overview, two virtual machines. One of them is going to be our Kali Linux virtual machine, and the second is just, in this case, is just a Windows host. We've turned off AV and firewall just for the case of simplicity, just to focus on the specific topics at play here. We're using open source offensive and defensive tools where we can. So Anartz is listed off there. So just some Python modules there, using Metasploit as we did last time, which you should be familiar with. And we're going to use Sigma rules as well. So we did touch on this last time when we were talking about some infrequent scheduled tasks. And this time we're going to be using them again. Just like last time, the recording for this will be made available after the workshop. And then the lab scripts should be available a little bit after that, so most likely tomorrow, I think. So what we're going to focus on for this lab or this workshop are two very specific log sources. So we're going to be looking at some of the endpoint logs that we can get for these activities. So we're covering off event logs, the various event IDs, and sysmon as well to augment that. And then we're going to touch on as well one instance where EDR or AV comes into play specifically to help us with regards to Defender. So I'm just going to hand over now then to Anartz, who's going to take it from here and deliver our code execution and persistence.
Oh, thank you for the intro. Hi everybody, my name is Anartz. I've been a threat hunter in F-Secure Countercept for the last couple of years, and I'm going to be presenting the webinar today. It's going to be based in code execution and persistence. It's going to be focused on those two methods. So, well, we're going to jump straight into it. I hope you guys enjoy and you take something out of it. We're going to start with a couple of brief introduction and brief definitions, just to make the base, to establish the base of what we're talking about. First is code execution. According to MITRE, code execution consists of techniques that result in adversary-controlled code running on a local remote system. This is actually a quite broad definition, but again, like code execution is a broad collection of techniques on its own. So it's kind of apt in that sense. What code execution really is any technique that allows the attacker to carry out or step out in the kill chain or step out in the next step of their attack by means of executing some kind of code in the target machine, in the target system. And it's a technique that even if it's categorized as its own technique, it's most often combined with different techniques or categorized in different tactics or underneath categorized underneath different tactics. And again, it can happen almost any point, or it does really happen at almost any point of the kill chain. Again, really, the amount of techniques, the range of techniques is really broad. It can go from something as simple as dropping a malicious file in a system and get a user clicking into it, executing the payload inside, to abusing like legitimate binaries that are already provided or already available in an operating system, and just abusing them to perform actions they weren't meant to, for example. And there are millions of other ways of performing code execution, but we're going to focus on these two today. So yeah, that's going to be our examples of code execution today. Regarding persistence, again, according to MITRE, it's a collection of techniques that adversaries or attackers use to keep access across system restarts. What that means is basically once a compromise has been achieved, the attackers are going to want to look into a way of keeping that access open, even if the user of that workstation like shuts down and goes home for the day, or there is a credential reset or any other kind of interruption. They're gonna try and find a way of keeping that access available, and that persistence is the way of achieving that. Again, a lot of techniques under this categorization. But the ones we're going to look into, and also like one of the most common ones, are the most of all the school ones, is adding a file to the startup folder of the user, or adding some kind of code to the startup sequence of the system, or also adding a specific registry key in a specific registry that will also load code at the startup, and therefore like granting back the access to the attacker. Again, the techniques we're going to see are really old school, but still working. There is actually the ones that the attackers used in the examples we're going to see. So yeah, like old but still rocking. So we're gonna check them out. Again, Astaroth is the malware campaign we're gonna base our labs on. And we're going to do that for a couple of reasons. First, I think it's an interesting malware because it's different in quite a few ways from other stuff we've seen. It's also been already alive for a while. It's been known for at least a couple of years, if not more. But it also has a last iteration not long ago in February. And this latest version presented some really uncommon means of achieving its goals. So I thought it would be a good idea to use this as an example or as a base for our labs. Again, the campaign we're gonna base off is the last one. So yeah, the malware has been around for years, but it has had a comeback this last February. It's still active as far as we know. So we actually have seen some of this, or we have dealt with some incidents regarding this campaign not long ago, like a few weeks or months ago. And what is it special? What is it known? It's mostly because a couple of characteristics we're gonna go over them now, but mostly because it makes a heavy use of leaving off the land binaries, which is a concept that we're gonna define and analyze in a bit, and in combination with other techniques like fileless techniques and like heavy obfuscation too, and also like other interesting ways of achieving or of hiding payloads, like using alternate data streams, which is also something that we're gonna look into today. So yeah, the two main points of this last iteration of the malware, as I was saying, like it's and the ones that we're going to focus on today is the alternate data streams and the use of lol beans, especially bits admin and export.exe, which is also quite uncommon binary to see used in this way. But again, very effective and gets the job done in a really effective manner. So it's the tool that attackers can leverage at any time. The main characteristic of this malware, it's stealthy. It's very stealthy. It's multi-component, by this meaning that it has several stages. It can once it's installed, it can download further modules to perform different actions, and also during the delivery, it also makes use of it actually divides the payloads in various parts, hides those parts into the alternate data stream of different files. Those parts are also heavily obfuscated, and when the moment comes, takes those divided or those bits of the payload, puts them together, and executes the next stage of the attack chain. We're also going to see that in a bit. As I was saying, makes use of heavy obfuscation, use of fileless techniques, abuse of lol beans. Most significantly in this last version, bitadmin and export.exe, and also abuse of the alternate data streams. Regarding persistence, it's not as fancy, it's not as advanced. Again, it goes a little bit old school in this way, and it achieves persistence by adding a shortcut file to the startup folder, and also adding a key to the user registry hive, which again is kind of known, or very known and common way of achieving persistence, but again, still works, easy to carry out. Why change it if it works? So this diagram of the attack chain of this campaign in 2020, this is taken out from a blog from Microsoft, the Windows Defender or Microsoft Defender ATP team. It's a really interesting read, so I really recommend going through it if you're going to also do the labs on your own later. I really recommend going through this article before doing that, because it provides a really interesting, a really good background on what we are gonna do in the labs and what we are talking about at every step. And it's also as a piece of malware, it's also quite interesting to see, just because it's quite uncommon in many of the ways in which it gets executed, or it gets it achieves their compromise. Just to quickly go over it, we can see the normal infection vector is an email with a link in it. That link in the email, if the user follows it, downloads a zip file that contains a shortcut file in it. And again, once that file and the shortcut file is in the system, the user clicks on it. And that's what spawns, or that's what causes the cascade of events that perform the compromise. First, it's just a bunch of bad commands that use explorer.exe to retrieve a one-liner JavaScript as a first stage payload. That one-liner reaches back to the server and download the next JavaScript, which is the main JavaScript that performs quite a few actions that are the ones that later come out together and perform the latest stages, the latest stages of the malware, the compromise of the attack chain. So to do these actions, the JavaScript makes use of bitadmin, which is one of the lol beans that we've been talking about and that we are going to show. In one first step, it downloads some encrypted binary content. This encrypted binary content is what I was referring to before. So this is various files, randomly named, heavily obfuscated, and they are payloads that are divided in these various files. They are stored in desktop.inis alternative data stream, and then when the attacker wants to, they get accessed. Those bits, those different bits of the payload get mashed together again, decrypted, and executed to form the actual payload, and it gets executed. That's one of the flows. The next flow is also using bitadmin again. Carries out the same actions of downloading divided payloads, rebuilding them, and then another of the characteristics of this malware is it makes use of export to once that payload has been put together again. Export looks for that payload in a specific directory and sideloads it and execute, and that payload gets executed. So that's actually as far as our lab is going to go. We are not going to follow the attack chain here. So at that point is where we are going to execute our payload, which is going to be a meterpreter cell that's going to connect back to our C2 server. And that's where we're going to conclude, or we're going to assume that our compromise is done. Again, take a look to the blog because it's really interesting and it really provides a lot more context into this thread. Regarding our labs, it's going to be divided in 2 labs this time. The first one is quite extensive. It's focused on the use of LOLBins, specifically bits admin and export and the alternate data streams. And it's using these LOLBins to download, execute, and hide the payloads. The second lab is going to be focused on persistence, and it's gonna involve copying a file to the startup folder, to user startup folder, and also adding a registry key to the user registry hive. Both methods of achieving persistence, and we're gonna try them afterwards and just make sure that we actually have achieved persistence in the system. So yeah, we're gonna start with the first lab then. Again, based in the LOLBins and the alternate data streams. I've already explained this, but just to go a little bit over it again. We're gonna do the main focus of this lab is gonna be to recreate a basic or a simplified version of the attack we've just seen. The reason of simplifying it is just to focus on the points we're interested in, but also to make it easier to anyone carrying out the labs on their own to grasp what we are talking about, to grasp the content and gain the necessary knowledge of the basic concepts that behind these techniques and why they work. Also, we're going to focus on the bits admin and export utilities, and also going to make use of alternate data streams to hide the payloads. Again, just as a reminder, these labs are going to be up. The lab guides are going to be up probably around tomorrow. So I really recommend if you guys want to go and carry out the lab on your own. It's really simple to set up. It's really simple to carry it out. Really interesting. So yeah, I really recommend you guys go check the guide tomorrow and try to do it on your own. Before we start, small definition on LOLBins, just to know what we're dealing with or what we're speaking about. So what are LOLBins? LOLBins are what are referred to as living off the land binaries, and with this means is, or what this term encompasses, are any binaries already available in the operating system. So we are referring to any utility that comes already bundled up in the operating system that are already available in the operating system. So and there are 2 reasons why these are really a really nice target for the attackers to abuse. Just because they are already available, that means they don't have to transfer any other tooling on their own to the system, which always is kind of risky. And at the same time, they don't have to modify them or do anything with them. Like as they are ready to be used and abused. And by abusing, what we mean is like these files, obviously, when they were designed, they weren't designed with the goals the attackers have in mind when they use them. So yeah, the thing is like attackers have found a lot of different ways of getting these files or these utilities to work in ways they shouldn't be expected to work in.
We saw a couple of examples, didn't we? Just last week, we used scheduled tasks and MSHDA to do a very, very similar thing. So it just shows their applicability to a lot of these different techniques.
Yeah, exactly. So as I said, like the last time I checked out, so you guys can check the repo that's referenced in the bottom of the slide. That's a really nice project that tries to list all the known binaries, LOLBins. And last time I checked, there were like 115 of them. Some of them are already like more common or known, like MSSTA or like the ones that Alfie just mentioned too. And again, like they are used and they are known because they work, and they are abused because they work. So, but yeah, this is just another a couple of examples of this group of binaries or of tools the attacker has at their disposal. Just a quick comment too, you might read or hear the term lolbus, and that's actually means it's just another term to refer to both lol beans, but it also includes libraries and scripts. Again, like readily available in the operating system, and just like just expands the toolset available for the attackers in that sense. So we're gonna jump into bitadmin, which is one of these lol beans we were speaking about. What's bitadmin? Bitadmin is actually the background intelligent transfer service admin that Microsoft developed. It was conceived to do like the main purpose is to carry out download and upload jobs. But again, like we have a couple of examples here. But if you go to the lab guide, you will find that there are a lot of, or if you do some research on your own, you will quickly find that there are a lot of ways of abusing this utility and for different goals. The most common one again is downloading, but you can actually execute files with this tool, and you can even achieve some kind of persistence with it. So yeah, it's supposed to be deprecated. Whoa, sorry about that. Yeah, it's supposed to be deprecated, but still, like it's included in every operating system, and again, it's widely abused by malicious actors. Export.exe. This one is not as common. It's quite rare actually to see it used this way, but again, it's really effective on what it does, and like having some malware using it actually is kind of interesting to see, and it's one of the reasons why this last version of this last campaign of Astaroth is interesting. So what's export.exe? It's a utility that comes bundled up with Internet Explorer, and that the way it is abused is that with this you can point this binary, this exe, to a given path where you are storing your payload, and then that payload needs to be in DLL form, and in one that's something like something that makes it also easier to detect, I guess. But so yeah, you point it to a given path, and if in that path there is any DLL named as one of those names that we have listed there, it will just pick those DLL up and sideload them, and effectively executing the code of the DLLs. So the way attackers have used this is easy to imagine. You have a payload in a DLL form, copy it to a public library, for example, a public folder or whatever, rename it as one of these names, and then executing export. It will automatically go to that directory, grab the file, the payload, and sideload it and execute it. You can see the command to achieve this on the right-hand side of the slide. And again, one of the like things that stands out of this one is like the format you execute it is like, again, pointing it to the path, but then you have to add 2 extra arguments. Those arguments are just dummy arguments. They don't have any utility and they can be named whatever. But if they are not there, this technique just doesn't work. So yeah, it's another thing we can check up when looking into this. So about alternate data streams, I only learned about them like not long ago, to be honest, but I found them really interesting. They are really interesting concept. The main reason why they are abused is because they are really useful to hide payloads in a system, or any file, actually, any kind of code in a system. So what they are? What are they? So alternate data streams are actually a property of every entry file, of every entry on the master file table. I think it's only you can only find it in the NTFS file format. But yeah, it it's used to store arbitrary data on it. Again, not the intended use, but because you can store any kind of, or almost any kind of data in it, it's easy to imagine that you can actually put malicious code in it, like a malicious file, to hide it in there, and then you can even access it and execute it from the alternate data stream, so you don't have to take it out from there to say so. So you just put it in there, it gets hidden, and you can access it at any time. So it's kind of like the perfect hideout for a malicious payload. Another really nice feature for attackers on this, using this technique, is that actually you have when you put the payload in an alternate data stream, that alternate data stream actually belongs to a file. But when you do it, when you add this file or this extra file, sorry about that, everything's coming up at the same time. I don't know why it's been quiet for the rest of the day.
It's the demo gods, and they
are. Yeah. hitting hard now. So yeah, as I was saying, like the format of the command, you can see I will see examples of this in a bit, but yeah, the format is usually the format for the data stream is the name of the file whose data stream you're going to use, colon, the name of the file you're going to append to that data stream, and then $sign and the type of data that file of that appended file to the data stream. And as I was saying, interesting about this is that even if you add a payload that's, let's say, like 100 kilobytes or whatever, the size of the file whose ADS you are using doesn't change. So, for example, in our example, we're going to see that that desktop.ini file we're going to use is like have a size of 0, and even after we add the payload to it, the size doesn't change. So again, a really nice way of hiding payloads in a file system. So yeah, let's start with the simulation, with the lab. First of all, I'm gonna go through the flow of this lab, of the attack simulation we're gonna perform. The first step is not actually the first step of the attack. We only need to do it to create the shortcut file that's gonna act as the infection vector of the attack, as the first vector of the attack. It's the file that's gonna resemble, or that's gonna recreate that file we saw from in the original diagram from the original thread, the one that the user downloaded and clicked on. So that file is the one that we're going to create with these scripts. It's just a bad file that uses a BBS script to create this shortcut file, and the dropper bad file, the create dropper bad file, again, like creates this dropper create dropper BBS script. The BBS script creates this shortcut file, and then the script gets deleted, so it's only the click me shortcut left, and that's where our attack is going to actually start happening. So yeah, let's say that I'm the user. I've received that completely non-malicious looking file from probably a completely non-malicious looking link somewhere, from like receiving an email for, again, like someone I don't know. But I'm a user. I'm going to click on it. And then that's going to spawn the first step of the attack, which is this file it's a dropper. It's actually a dropper, and what it's going to do is going to use bit-channel utility, the one we just talked about, to contact the server, the C2 server that we will also show how to set that up in a bit. But because we'll contact our attacking server, our C2 server, fetch a file from there. The next stage of the attack chain from there, which is actually the stager. The stager file is gonna execute that file, and then it's gonna delete that file. But before it deletes that file, obviously the stager is gonna do all its work, which we're gonna see now. So once the stager is in the system, the first thing it's gonna do two things. The first one is, again, use bit-admin to contact back with the C2 server and download the final payload. Which, if you see here, is on our server, it's named payload.dll. But another thing that this stager is gonna do is, once it downloads it, it's gonna rename it to one of the names we we listed for that one of the names that export is programmed to use. So yeah, it's gonna contact the server, download it, rename it, and store it in a public folder. The second thing it's gonna do again is the stager itself has another embedded VB script on it, which it's a script that will create the launcher for our final payload. That script, what it's gonna do is once the launcher is created, before the launcher is created, that file is gonna get downloaded and stored in the not downloaded, sorry, created and stored in the data stream or the desktop init file in this public folder. And once we have that init file or that creation file stored in the data stream and hidden in the data stream, then we can get rid of the script that we've used to create it. And again, like we're gonna have this really nice script hidden from any unwanted attention in the file system and available for us to access at any point. So what that also means is that for some reason our launcher gets deleted, it gets found and deleted. If we still have that launcher creation file in there, the attackers or ourselves, Google, still have the possibility to reach back to it and recreate the launcher. Again, once that file is stored there, the launcher creator script is stored there. It gets automatically executed, creates the launcher file. And again, the launcher file gets again automatically executed, uses export.exe with pointing to the target path, which in this case is where our payload is stored. And again, using export.exe, it will look for one of the names we've already listed, and if it finds some, which in this case it's gonna find one, the payload is gonna be side loaded and executed right away, hopefully granting us a meta-predator cell back on our C2 server. So that's the walkthrough of what we're gonna do in this first lab. So let's get to it. Demo time. Okay, this is when I bring up the VMs and I start praying for everything to work the first try. Let me bring up the VMs. As we've said, we're gonna use two VMs. The attacking machine is gonna be a Kali Linux VM. And the victim machine of the target machine is going to be a Windows 7 VM. Let me just bring it up again. There we are. So as you see, like normal machine, nothing going on. I'm going to bring up this folder, which is where we're gonna store our payloads. It's the users public libraries folder. Again, free to write in. So we're gonna use that to store our first payloads. And what we're gonna do is I'm going to bring up my Kali VM. Okay. Okay, I'm in. And what I'm gonna do, well, I'm gonna quickly show you guys, like, this is what I have stored in the server right now. This is the directory on the server where I have stored my payloads. You can see the dropper creation file here, the script, the bat script here, the payload, and the stager. So that's where admin is gonna reach to. I'm not grabbing it. Where admin is gonna reach to fetch these files from. I'm gonna, as a first step, as I was saying, this is not a real step of the attack. It's just to create the launcher the dropper that's gonna act as the first step of the attack chain. Again, we just need to copy it into the desktop of the victim machine or the target machine and just double click it and execute it, and we'll see that we have here, like, it just created a new file. This also, like, this is only to make it look more similar to the real attack. So the real attack also, like, creates a new folder, a new randomly named folder in this directory, and stores the payloads in there. So here we have what the user would first see. Like, let's say the user has downloaded it from the email, and now we're going to double click on this, and this is before doing that, sorry, we need to set up the both the server and the listener to get our connections back. As we were saying, to create the server, we're going to use Python, a Python module called simple HTTP server. So before we said that we actually fire up the server, we need to move to the same path where our payloads are stored. So because that's going to be the root directory for our server. And once we are there, we just execute this command, and this will set up the server for ours in behalf of ourselves. So this is.
Sorry, I was going to say this is exactly what we did last time when it was with Operation Cobalt Kitty. We saw Ricardo was using Cobalt Strike to host those files, so that the two like Microsoft FTP, JPEG and stuff. What you're seeing here is exactly the same principle. We're just using the simple HTTP server rather than the Cobalt Strike web server to do the same thing.
Yeah, again, like this is like one of the quickest or like quick and dirty ways of doing this, but for the for the purpose of this lab, is just like we get to get it running. But yeah, the concept stays the same. And we're also gonna fire up our MSF console and set up a listener. We're using I don't think if we've already mentioned it. We're using Metasploit to set up the listener as a C2 framework. It's out of this webinar to like explain how to set the Metasploit up. That's up to the reader to research. But again, like setting the once the Metasploit framework is installed, it's really easy to set the listener up. We're gonna use this module, which is a multi-handler, one of the most common ones to use. We're gonna set the payload, which is gonna be a Meterpreter reverse TCP cell. We're gonna set the host, which is gonna be this Kali Linux machine. That's where once the payload is dropped, is where it's gonna connect back to and retrieve the and contact us back. We're gonna set the port, which is gonna be 444, and we are just gonna run it. And there it is. So this is ready now. We have our server, we have our listener. The whole C2 infrastructure is up now. Going back to the Windows machine. So now we are ready to assume the user role again. And as a normal user, I'm gonna click in this file that's saying click me. So I guess it wants me to click it. Here it is. So this is the first bit admin we're talking about in the diagram. It's reaching up back to the server to fetch the next stage of the payload, which is the stager. And this is the second one, which is gonna reach and download the payload. We already can see them here. Okay. So we'll see that the job has finished. We can see the new files in here. So again, started with this spawned both the launcher, which is gonna be the stage or the file that's gonna launch the final payload. We have the payload itself, which as we've seen, we have it named as payload.dll in our server, but now it's named as one of those names we were speaking about. So we make sure that when we execute export, it's gonna actually find it here and side load it. And also we have the desktop.ini file here, but it wasn't here before. So another nice thing is that we even if the desktop ini file we're gonna use to store the payload, the launcher creation script in the data stream, in the alternate data stream, even if the file is not there, when we store the data stream in it, it's going to be created on our behalf. So that's a really nice thought. So thank you, Microsoft, for making life easier in that sense. And we're going to quickly check that the data stream of that file actually contains our file. A quick way of checking alternate data streams in the command line is just using the R, the capital uppercase R flag in the dir command. And if we do this, here it is. We can see the desktop.ini launcher create.bbs file stored in the data stream, and we can see that it's a data type file. The code or the data stored here is of data type. So nice, like everything seems to be working. The launcher is supposed to have also been automatically executed. So if everything has worked, we can go back to our Kali Linux VM and check that it has actually bring us a MetaProtector cell back, and here it is. So awesome. We got a foothold on the system, the target system. We are in. So time to celebrate, I guess.
Doing it live as well. Well done.
Yeah, I mean, again, I tried this like 1,000 times before. I'm still like shaking. So I still have another lap to go. So we'll see. Still, we need to hold the celebration maybe better for after the second lap. If we look into the server too, into the left side of the screen, we can also see the request that fetch the different other files on the attack chain, the stager here, and the payload here. So again, just to point out that it's named payload here, but it's been renamed automatically and stored in the library, in the public library folder. So yeah, everything has worked. We're happy. Like we have compromised the machine. So happy hacking times. Okay, so that's gonna be all for this demo. We're going back here, and now it's time to actually reflect on what we just seen and what has been going on here. So what we observe? First of all, we observe bits admin being used to download the payloads. We saw it 2 times, and like 2 different times, and both times was used to actually transfer a file from our server to into the target system. So how can we go about detecting this? Like what can we do to detect this kind of the users of bits admin? One of the, if we have Sysmon installed, like one of the useful IDs, event IDs in Sysmon for this is as ID1, which is process create. We can also correlate that with the event ID of. So the good thing about the admin is that it has its own log in. I don't know if we can see it here. If I go back. Okay, yeah. So it has its own log in the Windows event logs. It's called Microsoft Windows Bits Client Operational Log, and it's quite noisy. It can get quite noisy, but again, if a quick way of getting useful information out of it is just filtering by ID 59. What that ID will show us is, other than some of the normal information, it will also show us the URL or the IP to where that bits admin job connected to retrieve the file. So again, it's a really useful way of seeing what bits admin has actually been up to. Again, can be a little bit noisy, this log, but filtering by this ID can make things a little bit easier. So that's one way of detecting it. Another way, the thing with bits admin, as I was saying, is that it can be used in many different ways and for many different purposes. So depending on the purpose it's been used for, it's going to use different arguments. It's going to be use different commands. So each of them needs a specific detection mechanism. But again, like they are, most of them pretty well documented. There are rules out there, I think, for already made rules already there for to feed your CM utility to detect this kind of events. And again, if you want to have a better understanding or a deeper view of bits admin and the different uses and the different detection mechanisms, I recommend you guys go online and check the lab guide when it's released tomorrow to get a deeper understanding or a more broad knowledge of how bits admin works and can be detected. We haven't solved this, but again, one of those other uses bits admin or ways of abusing bits admin is actually doing it through PowerShell. There is a PowerShell CMD-led called the Start Bits Admin, if I'm not correct, if I'm not wrong. I think it's on the next slide. That can be used to perform the same actions that used normally, but if it's used that way, the good thing for us is that it also gets logged in the PowerShell logs. So that's another source we can use to to investigate or to ingest and filter on these events and monitor these events. Again, like this is the CMD-led. Again, let's start with transfer, the source URL and destination URL, so kind of similar to the command we've used, but this time like using PowerShell. And again, as I was saying, bitadmin is quite known login, quite extensively used. So there are already a lot of rules already created that we can use and fit in our CM solution and start monitoring for these events. In this case, we can see that what it monitors for, this is just the text downloads for bits downloads of bits jobs executed from PowerShell. And again, it just focuses, it just filters by the name of the image and the name of the contents of the command line, just the CMD-led name in this case. Additionally, export, we've also seen how export can be used. Again, this is used to sideload DLLs and execute them. It's actually, there is, I think, well, I actually know that with Defender tags for this or has alerts for this. From my experience, it's not 100% effective. It's a behavior-based signature, so it's not 100% effective. It's again still worth having, obviously worth having a Win Defender activated as a first line of defense, and it does catch a lot of these executions. But normally you would like to as with any kind of defensive mechanism or defensive system, you would like to have several layers to make sure that you're actually detecting all of the variations of the executions. In this case, again, like ID1, it can be useful for this detection. And here we can see the actual alert from Windows Defender. Okay, going back to, did I miss something? Yeah, I forgot. I'm using ADS to hide the piece of the attack chains or to hide the payload or the file. Again, this is harder to or more than usual. Just let me bring up one piece of. Bear with me a second, please. Okay, here. Yeah, so one way of or one of the most straightforward way of detecting it's not really straightforward because it's kind of tricky, but one of the ways of detecting is here, sorry. It's just checking for the like, for example, in our case, we have a rule created for this, which checks both for a list of suspicious images that are the ones trying to copy or trying to execute a file from an alternate data stream, and then it also checks for the arguments of these processes. So it tries to check if that argument has a colon in it, for example, and it also tries to check. It also checks the extension of the file it's starting to execute from the alternate data stream. And again, like it correlates to both of them. It also has some whitelisting that's been done after some thorough baselining on our client's state. But again, like that's a way of detecting it. It's just like at least detecting execution from an alternate data stream. It's just creating a rule that monitors for usual suspects processes that might be used to access malicious payloads, and then just checking that they are executing with arguments that correspond to or refer to an alternate data stream. Yes. Okay. So jumping into persistence. Let me just quickly check one thing, please. Okay, yeah. So for the persistence lab, again, I'm going to present a small diagram. on how the attack is going to be carried out. Where the first half of the attack is going to be the same as before. So we are going to the flow is going to change when we reach the BBS, the create launcher BBS script. That's when we're going to add some additional functionality to this script. That's the one that's going to be the step that's going to allow us to achieve persistence in the system. Like again, the first step this script is going to do is like before. It's going to get copied to the desktop ini data stream, and it's going to get executed, and it's going to create the same launcher as before. But at the same time, just after doing this, it's going to do a couple of other things. The launcher file is going to get copied to the user startup folder, which again, it's a common way of achieving persistence in a system, and at the same time it will also add the registry key to the user registry hive, like under the Explorer cell folders with the startup value, and it's going to point that registry key to the path where this launcher is stored. Okay, we're gonna just again, like this is what we're gonna use. So these are the two different things we're gonna use to perform the lab. Just adding the run keys in the registry and the file to the startup folder. We're gonna use these commands. Sorry. And yeah, so this is what we're gonna follow through the lab to achieve persistence. We're gonna jump straight away in it because I think I'm actually quite behind the time. So having a bit of a misclick nightmare here. Okay, going back to the demo machines. I'm just gonna delete all of this here because we're gonna restart the whole process with the modified files. Oh yeah, that's because I'm. Well, it doesn't matter because it's gonna get recreated anyway. So delete this, and we're gonna bring in files. Here. So I'm gonna move to a different path where I have the new versions of the attack, the new versions of the payloads for the attack, and I'm gonna copy them first one as before in the Windows desktop. There it is. That's the modified version. Okay. I'm gonna bring this back here, and I'm gonna move to the new directory too. So again, I'm in the new directory where our new files are. I'm gonna start the server again, and I'm gonna set up the listener too. Again, we're using the same infrastructure to set up our C2 server. We're gonna use the same exploit, same module. We're gonna set up the same payload, same host, same port, and run. Okay, so this is already set up. And here I'm gonna create the launcher file, which is this one. And I click it on it again. First bit's admin as before. That's gonna retrieve the stager file from the server. Second bit's admin. That's gonna retrieve the payload. Okay, and we have kind of the same picture as before, but I'm gonna show what's new here. What new thing has happened here? If we go to a startup folder that was empty before, I could should have shown that. We have the launcher here, so this has just been copied in there. That's one of the persistent mechanisms we're talking about. And if we go to the registry, we see, actually I need to refresh this, but here, see the normal key is in there, normal value. But if I refresh it, now we can see that it has changed to the path where the launcher is stored. So again, in theory, this could mean that we have achieved persistence in the system, but we're gonna test that in a bit. So first, we're gonna confirm that the initial payload has worked again. Here. Okay, again, server has received both requests, and we have the metapreter cell again. So we can confirm that the initial part of the payload still works. That's good. And what I'm gonna do is like I'm gonna adopt the role of the user again. Gonna go back. Office day is over. Time to go home. Have a couple of beers maybe. Well, maybe I'm already home now because like a COVID situation. But anyway, I still can have the beers here. I'm gonna shut down and call it a day. And okay, good. And I'm gonna go here. I'm seeing that here my session has died, obviously, because the system has been powered off. So what I'm gonna do is like I'm gonna start the listener again. And let's say a day goes by, new working day for the user, wakes up, has a coffee, boots up the system again. Like for him, nothing has changed, everything stays the same. Man, I do miss this Windows sound and intro from Windows 7.
I'm telling you, it's going to start installing updates now.
Yeah, probably. No, it's obviously it's not connected to the network. It's just like on local network. But I mean, it's Windows. Maybe it still tries. So I'm gonna log in. Oops. Okay, and again, like everything seems normal. Nothing has changed. But now, if I go to my attacking machine, here we are again. We have achieved another cell after the user has logged back in, and that just confirms that we have persistence in the system, meaning that doesn't matter how many times the user logs off, we will still have our foothold in there, and we can advance the attack from there. Cool, happy times. Going back to the slides. Again, a quick review of what we've seen. Again, we've added a startup file, a shortcut file to the startup folder, just as the real Astaroth does. Again, a way of finding or detecting that, it's checking Sysmon. The event ID 11 provides means or it's for as the event for file creation. Again, you can correlate that with other different sources or other different data. For example, like monitoring for monitoring for that startup folder, and I mean there are there is a really well-known technique. So there is a lot of rules that you can feed your CM, and there's a lot of ways of how this detection can be carried out. Again, there is if this is performed by the command line, the IDs change. The Sysmon ID 1 and event log ID 4688 also points to process create. So we can check the name of the process, for example, and the command line arguments to see and check that if that points to the startup folder, that actually can it's enough on itself to at least grant a quick look into it. And speaking of the registry key changes, again, interesting event log IDs 4657 and Sysmon ID 12, which it's a rec value create that also point to some kind of tinkering or like of change in the registry key. Again, this can be correlated with other sources or more info about the event, like paths. Again, process executing it. Again, like it's been gone over before in the previous lab, but again, like parent-child relationship that are with other most of the times add a really useful context to a process execution or to an event. Like again, arguments in some cases are specific enough that they can be used to at least filter them out or filter the file, a big number of the false positives out. Again, detection is really just it's just a matter of ingenuity or creativity and being able to use the resources at your disposal in the most effective way possible and combining them to create a better picture of the events that you are investigating. Here, the picture underneath actually shows the actual persistent mechanism or from one of the compromised machines we were dealing with. As you can see, the file gets started to the shortcut file is added to the startup menu and the key added to the user side. So again, exactly what we just done here, exactly the same as the original thread. So as I was saying, really old school tricks, still work, still efficient, so still widely used. And again, as I was saying, ways of using rules. Again, a lot of rules already existing for this kind of detections. These specific ones, the text looks for suspicious rank key elements that are pointing to suspicious folders. Again, like these lists are normally put up together after a lot of research or trying or baselining, but there are already quite a few known file paths and binaries and processes like and lolbins, for example, that are known to be widely abused. So again, filtering for those kind of indicators, it's a really good way of actually performing detection on this kind of actions. I haven't mentioned it too, but again, like autorun, for example, achieving persistence through autoruns, it's follows a really similar flow as these ones. Again, widely used, again, widely researched and like detection mechanism widely available. But again, it can be considered like kind of part of this kind of. So summary to start cutting it off, because I think I'm a little bit over the time. What did we do? So we explored that some techniques that are actually used in real world, in a real world scenario, in a real world malware campaign. We develop a simplified version of that real world attack to be carried out in a simple lab that allowed us to use like a few sets of tools like bitadmin, the abuse of ADS and DLL side loading, a few of these techniques, and like allowed us gave us the opportunity to both know and see how they are used by attackers, and also what also get to know a few of the options we have to detect them, or a few of the ways we have to detect them. Obviously, we're not trying to cover all of them, but we saw a few of them. And regarding persistence, the same. We also looked at some really effective ways of achieving persistence, really simple and effective ways of achieving persistence, and also how to detect them, or how to start at least investigating them, or creating, or where to start looking in case we want to create some detection system for them, some detection mechanism for them. A point I want to point out here. This slide obviously cannot fit here. It's not possible to fit here as much as we would like. The lab versions of the lab guide versions of this webinar again contain a lot more information on this subject, a lot more or a few more use cases for this lolbins, for example, or these techniques, and a few other ways how detection can be carried out. So again, I strongly encourage you guys to go and check them out, at least have a quick look, just to get a deeper knowledge of these techniques, both from the attacker side and the perspective and the defender's perspective.
It's worth mentioning as well, we had it in one of the questions on the Q&A, I think, that the scripts that you're going to use, or you're using now, are going to be in those lab guides as well, so you can actually replay what's happened. So don't worry about that, they'll be there.
Absolutely, I forgot about that, but actually I can just quickly, just to get like a sneak peek, I can quickly load them here, because I think I have them open. It's not the best code in the world, but it just does the job. So yeah. So this is the script or the path file to create the dropper, and this is the stager itself. So yeah, we can see here, for example, the VBS script creation script that creates the launcher. We can see here how it's copying the launcher to the alternate data stream and then erasing it. We can see how it's executed here. We can see how it started from the how export how it started by using export. And this is not the persistent version. The persistent version I have it in the folder, but again, in the persistent version of it, like the persistent mechanism is added after this bit of text. Again, it's not the best code, but it's quite simple and it gets the job done. It's like, again, a simplified version of the real thing probably, but enough to at least point out the core topics of this webinar. Next time, I want to invite you guys to the next webinar. I think it's going to happen in a week. Yeah, exactly. Yep. It's going to be delivered by Alfie, my colleague here, and he's going to look into the discovery and lateral movement techniques. Really interesting. So I really recommend you guys to sign up for it. The sign up link is below. And yeah, it's just follows the next step on the attack chain. So again, if you want to have the whole picture, it's worth just going over all the webinars and getting the full view of how of all the attack chain.
Yeah, nice.
Yeah, that's all from my side. Hope you guys enjoyed. And yeah, just wanted to give a quick thanks to Julio for keeping it up with the Q&A while I was doing the webinar. Now it's also time for any leftover questions. If anyone has any leftover questions, please just write them on the chat now, and we're gonna look through them. There is a little bit of delay, so it might take a little bit of time for us to get them. But yeah, just write them now, and we can try to and answer them. I don't know how much time we have left, though.
I can stick around for a few minutes, I think.
Okay.
Some other cool things I was thinking of just watching that is the Bits client, doesn't it have a specific user agent? Isn't it just like a Bits user agent? If you're just looking at your proxy logs, you could probably find instances of Bits clients talking out through there.
Yeah, exactly. So one of the things I also adding to that too. That's right. That's something you can actually look into. And in addition to that, another thing you can use in these cases, which we haven't talked about, are network events, and obviously network event logs. Again, there's a few fields that or a few sources you can use there to look up for specific information. Like you can also combine that with threat intelligence feeds to look for non-malicious URLs and things like that. So yeah, you can start building quite a sophisticated detection mechanism just from those different sources. Yeah. And again, it's the main point of how detection works is the ability to just be able to combine all the resources and sources that we have available in the most efficient manner and make it and just be able to filter out all the false positive and get just the meat or the actual malicious hits.
Yeah, because you could imagine a scenario. I think we might have spoken about this in the first workshop. The idea of if you were to find a compromise using the specific TCPs we've seen here, if you had the logs available, it'd be very easy to kind of start looking through both your proxy logs to find those bits admin, but then also, of course, your process creation logs to be that something that's exposed by your EDR or something exposed by Sysmon or otherwise, and start looking very specifically for that sequence of events, whether that's just looking for the bits admin client being used or the ext export or whatever it might be, but having all of those log sources available. Obviously, we've been trying to point out as we go very specific event IDs that are going to be useful, but actually combining them together, certainly when you're kind of just trying to investigate suspicious activity, is going to be the real the real deal.
Exactly. Yeah, just the same with, for example, for process events. Usually it's not enough with just the process. You usually combine that with other indicators, like a specific string in the argument or specific flags. So it's the same concept applies, I think, over all of the detection, really. Yeah. I don't know if there's any question. Can't see any.
Yeah, so we have one question here about the runkeep assistance, whether it's well, it said it's not really stealthy, and should it be detected by almost all security products? I mean, yeah.
I mean, it's one of the actions that bring the alarms. In this case, for this this scenario. So yeah, it's not the stealthiest way of doing it. Again, it's effective, but I mean there are a lot of more sophisticated and stealthier ways of doing it today.
Yeah, of course. So I think it's probably fair to say that when you've got some degree of access, especially administrative access to a host, like there's a million ways that persistence could kind of take place, right? I've seen some crazy stuff. I can't remember the blog specifically. I might have to link it afterwards. Of compromising the CLR, so adding an additional runtime. So when you load .NET, it produces you a shell. That's crazy stuff you can do when you've got access to a host like that. But yeah, quite rightly, run keys and startup folders are, I guess old school. But it certainly, I guess, it adds some new detection fundamentals for this workshop specifically. And it's I mean, if you want, it would be quite cool to take the lab scripts that we're going to release tomorrow and take those further and actually change the persistence techniques or change the lol bins that are being used to achieve it. That's all obviously things that you could extend for better, furthering out your understanding. But yeah, no, good question.
Yeah, absolutely. Like I like the way I'm using this webinars, like it's more like kind of just giving the basic steps. So again, like the lab is has a lot of references there too. So it's up to the reader to like once gone through them, like there is an endless options to go and check out. So yeah, just can start like building up from there really.
Yeah. Cool. Okay. Well, that looks like it's it for the questions. So I guess I say thank you firstly for doing the workshop, and I look forward to seeing everyone next week. Ricardo's abandoned me next week, so it will just be me. But I look forward to speaking to you then.
Yeah, man. See you there.
Cheers, guys. Bye.